is Pieter, and I'm here to talk about secure defaults or developer-friendly security. Secure defaults, sometimes called secure guardrails, paved road security, paved path security. I wonder if any of you have ever heard of this before. Can you maybe have a show of hands? I see some people who've heard about this. Who of the people who raise their hands is sold on this idea already? Not that many people. And maybe this is because we're in Belgium and there's a few Belgians here, because it's hard for us to believe in a concept like paved road security when our roads look like this. But there's some misconceptions around secure defaults, around paved road security, that might cause your disbelief in this idea. And paved road security, we talk about sharing responsibility of security with developers and the security team. But it is not just handing developers the bugs and having them fix all the problems. And it's also not just fixing high priority issues. It's more than that. And we'll go into this today. At its core, secure defaults means to make it easy to write secure code and make it hard to write insecure code. And that's conceptually very simple, but that is not what the security team has been doing historically. This is kind of what the security team is doing. If you consider water and the wetness bugs, security bugs, the security team is the one who's mopping up the floor, who's cleaning up the water. But behind their back, this is what's happening. Developers are producing more code, the tab is still running. We actually have a saying here in Belgium, dweilen met de kraan open, mopping the floor where the tab is still running. That is what is happening. And this might seem silly, and in reality with water, you will of course turn on the tap, but that's not what we're actively doing in security right now. We're not helping developers prevent new vulnerabilities. We're not helping them fix them or prevent new vulnerabilities from arising. So my name is Pieter de Cremer. I don't have a decade-long experience yet, but I started my career in a master in computer science engineering at Ghent University. And then I pursued a PhD at a company called Secure Code Warrior, also in cooperation with Ghent University. And this is a company with a large training platform and also a security tool. And I learned a lot about how developers learn security, what they know about security, and most importantly, how they can apply this knowledge in practice. 2 years ago, I was presenting at this very same conference my findings from my PhD. And there's a recording about this if you're interested. But it boils down to developers know much more than you think. It's just a problem of applying the knowledge in practice. I'm talking here about secure defaults, but there are plenty of people who talk about this. I've listed a few nice blogs and talks from Netflix, Meta, Microsoft, Google, and more. But today we'll go into secure defaults and why they exist, why it's a thing that we should do. So security must scale. Security people are understaffed, and the speed of development has significantly increased historically, and the way that we do security must scale with it. How can we do this? What are secure defaults? Secure defaults are making the secure way the easy way. We'll look at some success stories, like who is doing this, how are they applying these concepts, and finally, if I hopefully convince you that this is a good idea, we'll talk about how you can start. And the goal here is to think long term. How can I leverage my time effectively now to save time in the future? How can I make a bigger impact instead of mopping up the floor? How can I try to close this tab? So we'll start with security must scale. We've seen a talk this morning about SAST, and really SAST tools and any security testing tools have become very good. They find vulnerabilities in almost every application, and that is the truth. Every application that exists today has vulnerabilities. These vulnerabilities are problems in the underlying code written by developers. So developers are the ones who introduce these problems. But the frustrating thing is these are not new problems. We've seen the same problems decades and decades. I also have an XKCD comic. This one is about a SQL injection, actually. It's a fun thing where a son has a name, Robert, close quotes, close parentheses, semicolon, drop tables. And this comic was actually published in 2007. So in 2007, SQL injection was well known enough, was popular enough, that this was a joke in internet culture. We are now 16 years later in 2023. Do you still think SQL injections happen? Yes, they do. SQL injections or injection flaws in generally are pretty conceptually simple to understand, and developers do understand them, but they still happen. So fundamentally, we're doing something wrong to prevent this. And this is because traditionally security tools were designed with security people in mind. They were designed to test partially or completely completed code for vulnerabilities. They are reactive. The ones who use these tools and who find these vulnerabilities are security people, but who has to fix this, who has to fix the problems that we found, those are developers. And we are not actively handing them the right tools to do this. And this causes friction. The different teams have different responsibilities. The security team is the one responsible for the security of the code, but developers, they are producing new products, they are increasing performance and so on. They have a task of bringing value to the company. They are very important. And because they get priority, security is less directly related to income, to customers, to value. The security team has to fight for their importance. And there's some friction caused by lack of time. Security people, on average, there is only one security person for up to 220 developers in company. This means if they even spend 1 minute with every developer, they're busy for more than a month. And it's also a little bit lack of skill. Security people are not developers, but developers also are not security experts. There needs to be some better cooperation. On top of that, modern development practices have changed. With Agile, with DevOps, the speed of development has increased, and this benefits the security team. When their vulnerability is fixed, it's in production faster. That's a good thing. But it's also difficult because code changes all the time. There's multiple releases per week, even per day in some companies. The security team needs to keep on top of this. And there's some automations with CI pipelines, so we can now automate these tools on every PR, the security testing can run. But essentially, these are still security testing tools, not intended for developers, but for security people that we kind of force into their workflows. They are too slow. Developers are used to very fast, regex-based linters, things that give them feedback almost real time on the quality, on their syntax errors, and so on. While these SaaS tools like Fortify, or you're familiar with more of these tools, they are very powerful. They are very good at finding problems, at finding security things. They do this taint analysis that we've talked about this morning. They are very powerful, but they are too slow for developer purposes. It's good that we can find a balance here for security. And so what is happening is a shift left movement where we are automating these tools in PRs and closer to the developer, but fundamentally we are still using this reactive approach. We are scanning finished code and telling them what's wrong with it, instead of proactively trying to help them write it securely from the start. And this is because these traditional security tools use a reactive approach. We've seen code examples this morning, but I have more of a graph. In order to find a bug in this certain routine, we need to ensure that user inputs in some way can reach it. There might be a concatenated SQL query in this routine somewhere, and we want to make sure, well, is user inputs being concatenated, or if it's just code from a string from somewhere else. But it's perfectly possible at the time that the SQL query is written that no such execution path exists. So a traditional security tool at the time of development cannot find this problem. A very traditional security person would say there is no problem. But a month later, this routine can be reused from a different context, or a different developer might copy-paste some parts of this code, and then problems arise. So instead, we can be more proactive. This SQL query can just be parameterized from the start. It's a more proactive way to look for this, and we don't need the context. We don't need to do all these complex data flow analysis to determine whether or not we have a concatenated or a parameterized query. In case of parameterized queries, those are also more performant. So that's kind of the idea behind secure defaults. But to help developers do this, to help discover these problems, to help them apply these secure defaults in practice, we need to provide them role-specific tools and not security tools intended for security professionals. I talk about they need to be relevant to the developer's work. They need to be things that they understand that are applicable to their code base. Need to be efficient. They're used to real-time feedback. You cannot have scans that take an hour or more than that. And it needs to be usable and well integrated into their workflows. They like in the IDE. That's where they are used to getting their feedback. And it needs to be they need to understand what they need to do. You cannot just say, hey, this is a SQL injection, figure out what that means, go read OWASP cheat sheets. What you kind of want to do is, hey, I see you're writing a query here and it's not parameterized. Please parameterize it. You providing a solution just by detecting whether or not the secure default is followed. So I've talked about why we need secure defaults. The security must scale. We are understaffed security people and development speed has increased, and what we're doing right now doesn't work fundamentally. How can we do this? So what are we doing? We're making the secure way the easy way. I've used parameterized queries as an example, but I just want to emphasize once more the imbalance between AppSec people and developers, and this is not a number I made up. There's a talk by Netflix, and they actually have one security person for up to 220 developers. Just in crazy imbalance. So we need to make the security a shared responsibility. I know this sounds like just handing stuff to the developers, but that's where secure defaults comes in. We will try to help them do this. And we can only make a shared responsibility if we understand that there are shared goals. What developers want to do is ship features fast, improve performance, build code. What we want to do as security people is prevent vulnerabilities from happening in the first place. The easiest way to prevent vulnerabilities from happening is stop writing code. There's actually companies who do this. They have like a code freeze for a few days or a week where they do bug fixes, and then they know that no new bugs are introduced. But that's, of course, not the actual goal. The real improvement is when one can be improved without detriment of the other. We need to improve both. We need to keep adding features, and we need to improve security. And that can only happen when we realize that security is not special, even if all of us would love have a career in this. It's not special. It should be planned and scoped with all of the rest of the work. And to make this a reality, we can take a look at the DevOps movement. It used to be that there were operators that were responsible for deploying and operating the code. And with the DevOps movement, this is no longer the case. It used to be that developers write their code, and we've probably heard about this before, throw it over the wall to the other team, and they can deal with it. Right now, in the DevOps movement, developers are becoming responsible for deploying their own code, but they're not just left in the dark. They're not doing what operators used to do. They have Docker, Kubernetes, CI/CD pipelines. There's infrastructure to help them achieve this simple and more easily. And we need to do something similar for security. So here's an example of how an AppSec team might be spending their time. It's not completely fictional. At Google, actually 35% of their resources go to XSS. So it could be that this is what it looks like at your company as well. And for example, for secrets, for each of these, but for secrets in particular, you might be spending some time threat modeling, a bunch of time code reviewing, rotating secrets that have been leaked, and triaging bug bounties. You're spending a bunch of time on secrets with your security team. But instead, you can now start to think about a solution, a secure default. One example could be storing your secrets in AWS Secret Manager. It's a secure solution. It makes it easy to rotate, and it's very simple to use in different technology stacks. In Python, it's a few lines of code. It's also like that in Java. There's a bunch of standard ways to interact with the AWS Key Manager. And while you used to be reviewing different solutions, maybe your Python devs were storing it in an OS environment, variables, and your Java devs were using an exotic library, it used to be that your security team needed to research all these things. Every different project has a different solution, and they might be doing it correctly, but you're still spending time figuring it out, maybe testing, maybe looking up other people's evaluations of these libraries and so on, while by putting a secure default in place, it becomes a Boolean question. Are you using the thing that we agreed upon, yes or no? And in fact, a Boolean question is something that the developer can answer themselves, and you've made the use of secrets a self-service solution in security. So essentially, you've eliminated a bunch of time that you used to be spending on secrets. Maybe there will be some edge cases, like some weird technology or framework that they are using in some of your side projects that don't interact easily with AWS key management, but typically a lot of your time will be eliminated. We can look at the next vulnerability, SQL injection. I have a very simple example here. It's a concatenated SQL query. We have the get beer function, which takes the beer name, and if I were to ask any of you, is this vulnerable? Well, you need to know where this get beer is called. You can spend a bunch of time figuring out, does user input actually get here? Maybe you have like specialized data flow that SaaS tool cannot handle it very well or whatever. You can spend time on this, but actually the time that I spent about talking about this slide is already taking longer than just fixing the code. So find a solution that works for you in each project. Maybe it's parameterized queries or using a certain ORM or so on. But put something in place and make it the standard. Make it easy to evaluate, easy to, you don't waste your time on this anymore as a security team. I have a few more examples. You can no longer use direct responses, but use a framework to generate your HTML code. Or you can, for example, use sec-fetch headers to prevent cross-site origin attacks. If you want to learn more about this, I have a nice YouTube video about it. But so that's the idea behind the secure default. We need it because we want to spend our time more efficiently, and by putting it in place and help getting developers to adopt this solution, we will free up time in our security team. I have a few success stories that I want to go through. I'll start with first I want to talk about what does success look like. So I'm an academic. My ideal way to measure this would be, let's find a company that has two identical teams. They have the same skill, the same backgrounds, and let's have them develop the same app or the same codes, like duplicate work, and give one of them solutions with secure defaults, and the other them, they can do what they want. But in reality, that's not really possible. You don't find identical teams doing duplicate work, and when a company spends time putting something like secure defaults in place, you cannot hand this to only half of your developers. So in reality, we want other indicators of success. And they can look like this. We have, for example, classes of security risk being eliminated. If you suddenly see that almost none of your bug bounties or of your findings from your SaaS tool are SQL injection, that means that you're starting to do a good job. It can be that your average time to find and fix things has been reduced. Because you've put a secure default in place, it's now easy to understand what is expected of the developers, and they can do this faster. Or it can just be that the average severity is reduced, or your bug bounty costs are going down. Let's take a look at Netflix. I've listed a bunch of links to talks and blog posts by them because they do a really good job of this. And they used to do in-house consulting, basically, for their security team. They didn't have a good relationship with their developers. They didn't understand which apps to tackle first. They didn't have any clear priorities. They would just kind of randomly pick an application at scale, test it, evaluate it, and hand the results back to these developers. And that didn't work well. That doesn't scale. And they thought actionable self-service is important. Something that you need to know about Netflix is they have a very important culture. Something they always say is context, not control. That means you can give your developers or whoever is working there context. You can recommend them something, but you cannot control them. You cannot force them to use a certain static analysis tool or a certain way of working. You cannot force anything. So what they decided is we need to invest in partnerships. We need to talk to the consuming team of the secure default that we'll develop. We need to get them on board. We need to know what they want to solve, and we are not the ones leading this. They are our customers. So they go to a team and they ask, hey, what's something in security that you're concerned about, that's bothering you? How can we help you? And you don't talk about anything else than what they suggest. That's how they started. One of the things that they then also did was they noticed that very frequently these teams were having problems with authentication. It's one of the most common things that they saw in their across their organization, missing or incomplete authentication. So the security team started building they called it Wally, a different application, a different service that can be talked to from any app with any technology over an API that does authentication for them. It had everything. Storing passwords, protecting from brute force attacks, session management, basically everything you need for authentication. And they saw no organic adoption at all. Until they started adding features that were helping developers. Something that is important in Netflix apparently is for every application they have a sort of config file that helps asset management keep track of whatever is in this organization being built. And so there had be domain names and a bunch of configurations for these applications. And so what they started doing with Wally was reading these configurations and setting up stuff automatically for developers. And only at that point did Wally become adopted by a lot of teams. Suddenly, the easiest way to get an application internet-facing was to use Wally. You can read more about this on this blog post, but essentially what we want to learn from this is you need to productize your secure default. It is a thing that you build and you need to talk to your customers. What is preventing you from using this? How can we help you adopt this more easily? They noticed a few benefits from doing this. So these paved roads is what they call it, these secure defaults, simplified reviews of code. It became a Boolean question, as I suggested before. Are you using what we built for you, yes or no? And they also noticed that, well, security is not the main motivator for adopting them. You need to make it attractive for developers to use. I'll have one more example for Meta, Facebook. They have defense in depth is how they call it. They do a bunch of things like building secure frameworks, secure defaults, all the way down to pen testing and a bug bounty program. And in their secure defaults, that basically looks like this. They take it one level higher than building a service. They basically build Hack, an extension to PHP with typing information that makes it easier to analyze it. And they also built an augmentation to PHP Hack that integrates with HTML and basically escapes for the developer. So they effectively eliminated cross-site scripting from their code this way. I also want to talk about a smaller company, SemGrab, which is where I work. We don't have an internal security team. Well, we do now. We have 2 people, but we didn't used to have one. It was completely self-service by our security, by our developers. But still, we noticed that there were always fast resolutions. And the security team that we have now can focus on higher impact work and not just fixing the next bug that developers introduce that we're aware about. And basically, I have an example here. What happened was when trying to debug a certain problem, the log level was changed to debug level instead of error or warning, what it was set to. And suddenly, our developers saw that tokens were being logged in the logs. Sensitive information that shouldn't be there. So the first thing they did was, of course, revert this logging change and think about how to solve this. And they could have solved it for this particular case, but instead they thought, well, these logs are generated by SQL Alchemy or database interaction scheme, and basically how something is logged depends on the type of the column in our table. And so they replaced the string with an obfuscated string type, and they told SQL Alchemy, well, things that are obfuscated string type should be just logged as asterisks. And the next step is, well, from now on, for every sensitive information, this is what needs to happen. Obfuscated strings should be used, but how will you get your developers to do that? Some options are, well, every time someone makes a change to a SQL Alchemy model, they need to flag it for a security review. Or maybe you could do a yearly training on the pitfalls of logging sensitive information. Or you could do, look at the logs every week to make sure nothing is being logged. Or you can maybe ask your SAST provider to update your tool, to flag things like this, but actually the best solution is none of these is to use customized rules in your environment to get your developers to understand using these obfuscated strings is what you want to do. And with SemGrep, you can customize very easily and add these checks in your IDE or to your CI environment to make sure that anything that looks like an email or that resembles sensitive information can be enforced as an obfuscated string. So we've talked about why security must scale. Developers are understaffed, development speed has increased, and we've talked about what secure defaults are, making the secure way, the easy way, and we've seen how Meta, Netflix, and SemGrep does this. Now I want to teach you how to start yourself. And it boils down to thinking long-term, thinking high impact. So thinking long-term, don't start mopping up the floor, but instead try to close your tabs. Doesn't matter if it's completely airtight, you want to have a big impact on reduced water on the floor, basically. And thinking high impact, well, go for the tabs that are spilling most water on the floor. If you have a team that sometimes makes a vulnerability, a cross-site scripting problem, something like that, or you have a team that's consistently producing a lot of code, well, focus on the things that you will spend most time on in the future. So I boiled it down to four steps. First, we will select a vulnerability class. Then we will build a scalable solution and make it the default, make it the secure default. We will measure adoption and then try to drive organic adoption. So how can we select a vulnerability class to focus on? Well, we focus on the best return on investment. So you want to maximize impact, but not impact on the business. You don't focus on the most impactful, expensive problems. You focus on the problems that will maximize the impact on your time as a security team. What are you spending most time on right now, and can you reduce for the future? And that's what I mean, reduce risk. It's not possible often to eliminate everything. There will always be edge cases where some teams cannot adopt your security defaults. Don't try to cover everything. Just make sure that the time that you invest right now reduces your time in the future as much as possible. And by doing this, we can eliminate bug classes or eliminate the time that we spend on bug classes. And this time frees up in the future to build the next secure default. So we will have a compound effect. We will build a scalable solution and make it the default. And essentially, there's a few options when there's a security problem in code of what your security team could do. They could detect lack of a secure default, or they could find a bug. They could use SAS to make sure that currently there is some user input flowing to this sync, this insecure pattern in the code. You could do some manual inspecting, like, am I sure that this thing that looks like user input sanitization works correctly or not, and maybe you'll try to find an exploit that gets around an incomplete sanitization method or something like that. You can spend a lot of time on some of these problems, but for the effect for your company, it's the same. You want to write secure code, you want to eliminate this problem, and you can do this by spending way less time on it if you choose an option from the left. And then we will try and measure adoption. It's important to see the effect on your team or on your code. So we will track the cost and time per team and per class, so we can see which teams are adopting it and which are not. And that makes it possible to talk to the teams who are not doing it yet. Why are you not doing it? What is missing from my secure default? How can I make it easier for you to adopt this? So you have to speak to your customers. They are essentially your customers. You are providing them a service. That's how you need to look at it. But also, by measuring this, you provide friendly peer pressure. In my company, we saw a weekly report of the amount of bugs being reduced. It was like a nice table. It was not necessarily security bugs, just bugs in our bug tracker. And one day they started doing this in colors per department or per team. And you saw some departments slow down and other departments, they just kept a big part of the bar. And suddenly that provided peer pressure for those companies, for those parts of the company to also start reducing bugs. So some friendly peer pressure can also help adopting your secure defaults. But the best way, if you have the bandwidth, is to drive organic adoption. You will do this by productizing your secure defaults. So while a lot of people will say that by making security a shared responsibility, developers need to learn security, it also means security people need to learn development. We will productize, we will talk to our customers, understand what is missing, understand how we can make it better for them to adopt these secure defaults. And that sometimes means adding non-security features to make it more attractive to use. But until you have the bandwidth to do that, you can try to automate checks to observe and maybe enforce adoption if that's how you want to go in your company as well. But be careful when you do this. Do it the right way. Use developer-oriented tools. And the concept that I want to hand to you to help you do this in a good way, to help do this in a developer-friendly way, is a concept of an effective false positive. I have a link to a paper down below. This is a tricorder, is a tool by Google that they use in-house, and it's a very interesting paper. They talk about effective false positives. So classic false positive, a marking by your tool that is not actually insecure. It's an incorrect marking if you look at it from a security perspective. An effective false positive, just forget about the actual security of the code for a minute. An effective false positive is a marking by the tool that the developer does not fix, regardless of the security. So my example here, concatenated SQL query, it's perfectly possible that this is actually secure, and a marking by a tool would be a false positive. But if it's very easy to understand, very easy to fix, and the developer decides, hey, I'll just parameterize this query, it's not an effective false positive. The other way around is also possible. You might have a very complicated security issue touching lots of parts in your code that's very clearly a true positive. But the developer, since it requires a lot of work touching multiple parts of the code, maybe he or she doesn't understand it as well, decides not to fix it or not to fix it yet, or they think the impact is not high enough and it gets pushed to the side. You do have an effective false positive. So this was true positive from a security perspective, but an effective false positive from a developer's perspective. And effective false positives is what you want to worry about when you give stuff to developers. Sure, whatever your security team is doing, you probably care a lot about true positives and not looking at every possible bug, every possible marking. But what you hand off to developers, worry about effective false positives. And how can we do this? Well, we can make it more relevant, efficient, usable. And an example that I have is customizing rules. So we will make our tools more relevant by customizing the rules. I have collected a bunch of stats here about tools that do or do not customize rules. I know CodeQL you can customize, but this is the fix rate they report when they don't customize their rules. They claim an industry-leading fix rate of 60%. I have a few others: early security vulnerability detector, spot bugs. OWASP Aside is, I think, more or less a dead project. It's application security IDE. And then we have Tricorder in the paper that we mentioned, and Sensei is a tool that I researched during my PhD. And these two have a high focus on the customization of rules. So Tricorder automatically disables rules that have too many markings or that not enough interaction. They really focus on only showing the things to developers that they are actually interacting with. And of course, that means you'll have a high interaction rate with the stuff that's left. And with Sensei as well, I made a bunch of developers do a programming assignment and give them very, very customized rules to that assignment. And that caused, of course, a big interaction. Every marking was actually tailored to that project, to those libraries. Are you using this library that I provided or doing something on your own? And you can automatically see that customizing the rules creates a lower effective false positive rate, a higher fix rate. Another thing that heavily impacts the effective false positive rate is the remediation guidance, so helping developers. It's important that you find things for them to do, but it's even more important to show them how it's done. And with secure defaults, that's exactly what you're doing. You're not saying this is a cross-site scripting, this is a SQL injection, this is this type of vulnerability. No, you're saying you should have used parameterized queries. You should have used the framework to generate HTML code. You should have used the AWS key store to store this secret. You're essentially already telling them the solution. And a tool can then automate this solution for you. And this is what I did. Again, a program assignment. I gave a bunch of developers all the same assignment to complete a web application. And some of them received this, all of them received the same feedback from the tool, but some of them received automated fixes. On the left hand, you can see that the amount of markings, the amount of violations introduced during the assignment for both groups was about the same. The statistical test showed that there was no significant difference, so both groups have the same skill level. But at the end of the assignment, 79% of the group who received remediation guidance ended their assignment free of any markings by the tool, while there was only 6% for the group without remediation guidance. So you can see that there is clearly reduced effective false positives. Because of this remediation guidance, the developers know what to do. And we see this at SEMrup as well. The rules with an autofix have a 50% higher fix rate compared to rules without an autofix. So yes, I talked about why we need secure defaults. Security must scale. Security people are understaffed. Development speed has improved. A secure default means that we make the secure way the easy way. And we've seen how Netflix, Meta, SEMrup does it, and how you can start by thinking long-term and high impact. So let me end on secure defaults is not just having developers fix all security bugs, but it's building scalable self-service solutions. You don't let them do this on their own. And it's not only fixing high-priority issues, but it's killing high-impact bug classes to free up time in your security team. It's a TLDR if you want to look at it later. And that's the end of my presentation.
For a few questions. Are there any questions?
You mentioned Wally and Netflix. I was wondering if you have other examples, for example, just like parameterized query. Are there other examples? Because that's not really making life easier for developers. Adoption is attached to one of the targets.
So your question is why parameterized query, how you would drive adoption of parameterized queries, essentially? Yes, maybe a parameterized query would be difficult to productize, but there are, for example, libraries or ORMs that make it easier to query without writing actual SQL, or there can be some solutions that make the life of a developer easier. But I understand that this, as an example, it might not be the easiest to productize. So, a solution like Wally or programming framework like Hack or GSF or any other framework that automates a bunch of stuff is easier to productize even if you haven't built it yourself.
Okay, thank you. Are there any more questions? You gave an example to create two parallel teams. Obviously, that comes with a budget. You mentioned that. But don't you think, because in my previous organization at Semantic, what we used to do, like who were the developers, testers, and security researchers are there. So we used to unite all of them and organize a hackathon every year. And what used to happen, like different teams and people used to participate irrespective of their names and designations. And when they see the result, and they also learn, it's kind of engaging all your employees to learn like what should be secured and how it should be secured. And then we used to share the videos, what kind of bugs that the security teams have found, and how developers can actually fix it. And that helped a lot inside the company. It also helped in reducing the cost for the fixing the issues.
Yes, that's really an educational aspect of educating the developers. Learning them to see the impact of a bug and how easy it can be to fix some high impact things. is of course very important. But what I found during my PhD is that all of the developers actually have this knowledge. They understand what an injection flow looks like and how it works conceptually. It's just that during development, they are focused on the product that they're writing, the functionality of the codes, the non-functional requirements, and it's hard to keep track of everything at the same time. It's a large cognitive burden. So I feel with the right tools, we can help them apply their knowledge in practice. But of course, there needs to be knowledge first, so training is definitely part of it. Do we still have time to take more questions?
One last question there.
Yeah. Do you have examples of smaller scale companies where this is actually being implemented? Because from personal experience, in product or application development, it's difficult enough to associate time for security bug fixing, then actually asking management to provide operational budget to invest in the development of automated security tools, which takes more time initially than reactive fixing, is a very hard sale. Netflix and Meta as examples, okay, sure, they're big enough, they probably have that maturity, but
so the example that I give SendGroup, we had when we did this about 40 developers, and I have one that I cut out of this presentation in just a time, Snowflake, which is also a smaller company, but what it boils down to, what you said, it's not the size of the company that matters, it's the culture and the higher-ups deciding that this is something they want to invest in. And of course, if you are still very limited, it's hard to prioritize and you have compliance to take care of. It is a difficult problem to solve, what you're describing, and it is one that I still hope to learn more about in the future. Maybe in a few years I can come give you the answer. So if you are interested in working with me and helping you fix that problem, because I want to understand it more, you can always send me a message.
Or we talk over dinner.
Sorry?
Or we talk over dinner.
Yeah, that's good.
Hey, thank you very much, Pieter.